Greetings everyone. In this video we're going to solve linear programming 2020 internal exam. Okay, so without wasting much of the time, let's get started. So this is the question we are given here, and the statement read: a carpenter intends to manufacture at least 10 tables and at least 20 chairs. So before I proceed, what I always advise students is that read the question first here, given that, which is this one, given that x represents the number of tables, so that we don't waste much time calculating, okay, or just reading the statement. Given that x represents the number of tables and y the number of chairs, okay? So x is for tables and y is for chairs. Write 4 inequalities which represent these conditions. This is very simple. Okay, these are just cool marks, 4 marks. All right, so let's write the conditions here. Okay, this is question, you write question 12. So I'm writing with a pen for illustration purpose, but make sure to use a pencil. This is question 12. This is question 12. All right, question 12a. We are given we are asked to write 4 inequalities where x represents the number of tables and y represents the number of chairs. So in the first statement here, a carpenter intends to manufacture at least 10 tables. Now, at least, it means greater than or equal to. Since it's tables, then it's x. X is greater than or equal to 10 here. Greater than or equal to 10. This is the first inequality. The second inequality is another at least, which is greater than or equal to, but in this case is chairs. So the variable representing chairs is y greater than or equal to 20. Okay, this is the second inequality. Then the next statement says each table requires 4 hours to assemble or of assembling and 22 hours of vanishing. All right, each chair requires 3 hours of assembling and 1 hour of vanishing. There are 240 hours available for assembling and 100 hours for vanishing. All right, let's write the inequality here. So the first one, let's write the inequality for assembling. Okay, so each table requires 4 hours of assembling. Table is x, so 4x plus, this is for assembling. All right, then each chair requires 3 hours of assembling. Okay, each chair requires 3 hours of what? Of assembling and vanishing. So we are not going to read this one because the inequality is just here. All right, this one is 4 hours of assembling and 2 hours of vanishing. All right, 2 hours of vanishing is for just a table. All right, so we're not going to use a 2x here. No, we're going to get this inequality which is here, or this statement which is here. Each chair requires 3 hours of assembling. So you have this assembling here and assembling which is this here. So it will be just 3y. Now, the hours that you use for assembling chairs and assembling tables, and chairs should not exceed. Okay, should not exceed the maximum hours we are given here for assembling, which is 240 hours. All right, 240 hours. Then another inequality So you can reduce if it is reducible, but this one you can't reduce because we have a 4 and a 5. So you can't, 4 and a 3, sorry. So you can't reduce. The fourth inequality here will be for vanishing. 2 hours of vanishing. Okay, vanishing a what? A table. So you have 2 hours. This is for assembling and this is vanishing. Plus, how many hours are allocated for vanishing the chairs? 1 hour. So which is just 1x or 1y, which is just the y. Alright, should not exceed the allocated time, which is 100 for vanishing. 100 hours. And these are the 4 inequalities here. Okay? These are the 4 inequalities. Alright. So having written down the inequalities, let's plot them. Alright. Now, before plotting them, we need to read the statement here. So we're going to question B. Using a scale of 2 centimeters to represent 10 pieces of furniture on each axis. So this table, each table here is a 2 square centimeter. A 2 square centimeter each. So now we are told that we should use 2 centimeters to represent 10 units on both axes. Okay? On both axes, and we should draw the x and y axis for in the x axis 0 to 70, in the y axis 0 to 100. All right. Okay. So having this information, let's do the needful. Okay. So let's start from here. This point. So we have 0. Since we asked to use 2 to represent 10 on both axes, this will be 0. This will be 10, 20, 30, 40, 50, 60, 70. All right? And this is the x-axis. All right? The x-axis. Then this is the y-axis where we have 10, 20, 30, 40, 50, 60, 70. This is the y-axis. Now, in the x-axis, this is the number of chairs, the number of tables, number of tables. Then, in the y-axis, let me just turn this one like this. In the y-axis is the number of chairs. All right, number of chairs. All right. So I always recommend starting when plotting a linear inequality, starting with the easier one. These linear equations, these that are straight and straightforward, x or y. Okay. So let's start with x. Since this is x is equal to 10. This is here. This is the point where x is equal to 10. Okay, let me just do this. This is the point where x is equal to 10. So let me just draw a line where x is equal to 10 here. It's a solid line because it's greater than or equal to, there is or. All right. So on the graph, please don't write inequalities here. Use equal signs, you write equations. So this is x is equal to 10. Now, where to shade? Very, very important. Where to shade? Since this is greater than, then we are going to shade on the less than part. This is the greater than part of the graph, and this is the less than part. So we are going to shade this side. This is the side we are going to shade. Okay. This is x is equal to 10. Another one is y is equal to 20. This is the line y is equal to 20. It's also a solid line. y is equal to 20. Okay, and then it's greater than. If you look at the inequality is greater than, so we're going to shade on the less than part. This is the greater than part of the y-axis, and this is the less than part of the y-axis. And this is y is equal to 20. We are shading downwards. Okay, all right. Okay, so the next inequality is this one. So let's just solve this inequality first before we plot. Okay. So let's solve this. This is 4x plus 3y is equal to 240. So let's just form a table. This is x and this is y. Let's put 0 here and put 0 this side. So when x is 0, what will be the value of y? So the value of y will be, we divide by 3. This is 240 by 3 by 3. Y will be equal to 8, 0, which is 80. All right, 80. So when y is 0, 4 will be 60. When you solve, 4 will be 50. 50, 60, this will be 60 because it will be 4x is equal to 240 over 4, x is equal to x, 4 into 24 is 4 into 24 is 6 times, so this is 60. Then we just plot these coordinates here. Okay, you have 0, 80, 0, 80, which is just here, somewhere here. Then the other one you have 60, 0. 60, 0 is here. Okay, so we're going to connect this point and this point on the graph. All right. So you have this point, which is 80, and this point, and this is a solid line. Okay, a solid line. This is 4x plus 3y is equal to 240. We are going to shade, since it is less than, the wanted region is on the less than part this side, we're going to shade the opposite, which is the greater than part. Okay, this party. Okay, this is the party we are going to, well, we are shading, and that's the answer. The last inequality is, let's solve, is 2x plus y is equal to 100. The same table, just this is x and this is y. Put 0 here and 0 on the other side. When x is 0, y will be 100. Then when y is 0, x will be 50. Okay? So 0, 100, 0, 100, since this is 80, 90, 100, somewhere here. All right. Then the other one is 50, 0. 50, 0 is here. Okay? So let's just draw a line. Okay, like this. So this is the line. Okay, sorry. Okay, so this is the line. Okay, this is the line, and This is the line which is 2x plus y is equal to 100. 2x plus y is equal to 100. The shading automatically is on the greater than party. Since the wanted region is here. Okay? So this is the unwanted region. Okay. Alright, so we are done answering the second question. We are done answering the second question. Let's go to the third question, which is question C. Okay, and it's worth 2 marks, and the last one 2 marks. So here, the question we are given here is that each table sold yield a profit of 300, while each chair sold yield a profit of 250 kwacha. Find the best combination of the number of tables and chairs to gain the maximum profit. All right, so first thing first, we are going to come up with an objective function. An objective function is the function we're going to use to maximize profit, to find how we can maximize profit. So this is question C. So let's use this party, question C. So objective function, I'll use Z. Z is equal to, so objective function is going to be found by using the profit we are given here. So since table is X, so this one will be 300X plus 300X plus 250Y. I mean, yes, 250Y. Okay, 250Y. All right, 250Y, which is okay, 250Y. So we're going to test these coordinates. The wanted region, we have this coordinate here, 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 and here. So we have 4 coordinates. Let's test them. Okay, let's test them and see which one will yield the maximum profit. The maximum profit. So using my calculator here, we are going to start with, let's start with this coordinate which is here. All right, this let me just do this. Let's start with this coordinate which is 10, 20. All right, 10 is X, 20 is Y. So this will be like this. Oh, sorry. Okay, will be 300 multiplied by X, which is 10, close bracket, plus 250 multiplied by 20, which is here, multiplied by 20 is giving us 8,000 as profit. Okay, when we use 10 tables, when we order 10 tables and 20 chairs at the profit of 300 and 250 respectively, we are going to get 8,000. Let's use another point quickly. Okay, so let's use this point which is 40, 20. So we have 300 multiplied by 40 plus 250 multiplied by 20, which is here, Y 20. It's giving us 17,000 as profit, 17,000. All right, so this one is greater than this one. Let's use this one. Okay, so this one is so since this is 20 and then this is 30, so each box here is 1. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So this is 29, comma, so this is 40, 41, 29, 41. So 29, so 300 times 29 plus 250 times 41. We're getting 18,950, okay, which is also bigger than this one. Here we've used 29,41. Okay, let's test the last one, which is here. This one is 10, 60, 61, 62, 63, 64, 65, 66. 66. Okay, so 300 multiplied by 10 plus 250 multiplied by 66. 19,500. 19,500. So this one automatically is, we're going to get this one, the coordinates which are 10, 66, because it's giving us the highest profit, which is 19,500. Okay, so when writing here, it will be like this: Z is equal to 300 multiplied by 10 plus 250 multiplied by 66, which is giving us as the objective function or profit 19,500. Okay, therefore, okay, so we are asked to how many combination. Okay, find the best combination. So the best combination is that we need 10 tables and 66 chairs to maximize profiting. All right, that's all. That's the answer. D. So D, calculate the estimate of the maximum profit. So to find the estimate of the maximum profit is very simple. We've already found that one. Just to copy this equation, which is just Z is equal to 300x plus 250y. 300 multiplied by 10 times 250 multiplied by 66, and the answer is 19,500, which is the estimate maximum profit. All right, so we are done solving this question. Okay, this question is very simple, just to do a lot of practice, and it's very easy. Thank you very much. Let's meet in the next video where we'll continue solving examination questions. Thank you. Remember to subscribe.